So, have you ever found yourself just overwhelmed? Maybe staring at some really complex technical decision?
Yeah, and trying to figure out, is this really the right call for the long term?
Exactly. Or, wading through these super dense reports, just hoping for that one key piece of insight.
Definitely been there.
Well, you're not alone. Today, we're doing a deep dive into something called architecture governance.
Now, I know what you might be thinking. Sounds a bit dry.
Right. Maybe a little academic, but honestly, trust us on this one. It's all about making really smart decisions.
Decisions that can save companies and, frankly, you a lot of hassle. Headaches, time, money.
Yeah. So when we talk about architecture governance, what are we really talking about?
Well, think of it like guardrails.
Yeah.
Or guiding principles
Okay. For what?
for helping organizations build systems that are robust, scalable,
Yeah.
and really adaptable to change.
So it's not just about building a system.
No, it's about building the right system,
Yeah.
one that's going to last, one that can evolve.
And what's really fascinating, I think, is how these technical choices ripple outwards.
Absolutely. They have huge business implications.
Yeah.
Huge.
Affecting things like cost, quality.
Everything. Cost, quality, how agile you are in the market, even long-term growth potential.
Wow. So it's really where strategy meets the road, operationally speaking.
Exactly. Strategic vision, operational excellence, they have to come together.
So for this deep dive, where did we pull our information from?
A real mix. We looked at a pretty comprehensive presentation specifically on architecture governance,
Okay.
plus public info, industry frameworks like TOGAF, you might have heard of that one.
The open group standard, yeah.
Right. Vendor documentation too, and just common practices you see across different industries.
Like retail, convenience stores.
Yeah, even places like that. And we've got some really interesting case studies. Netflix, for example.
Ah, their scaling story is legendary.
It really is. And we'll also look at the flip side, some cautionary tales about technical debt.
Okay, good. So what's our mission here today?
Really, just to unpack what architecture governance actually is, why it's so critical for any organization using tech today.
And maybe explore how different approaches can lead to really different results.
Exactly. Turn these sometimes abstract ideas into practical insights you can actually use.
All right, let's dive in. The core. What's architecture governance trying to achieve fundamentally?
At its heart, it's about finding that sweet spot, the right balance
Balance between what?
between defining the role of enterprise architecture in the organization, blending creative thinking.
Like customer-centric approaches, design thinking.
Yeah, that kind of thing. Blending that with real architectural discipline, using structured methods.
Like an architecture development method or ADM.
Precisely. It's the framework that guides you from that initial spark of an idea.
All the way through to, say, an MVP, a minimum viable product.
Right. And then
Cool.
beyond that, through all the subsequent versions, the improvements.
So it's a continuous journey.
Absolutely. Success really hinges on two things running in parallel. Continuous exploration.
To find that problem-solution fit, make sure you're solving the right problem.
Exactly. That drives your strategic excellence.
Yeah.
And then continuous delivery,
For product market fit, making sure the solution actually works in the real world.
which is where operational excellence comes in. It's always about balancing these forces.
Forces that often seem to pull in opposite directions, right?
Totally. You've got cost, quality, agility on one side,
And value, market growth, speed on the other.
and architecture governance is kind of the compass you use to navigate those trade-offs.
Okay, it's one thing to talk principles, but let's see it in action. You mentioned Netflix.
Yeah, their move to the cloud.
Yeah.
I mean, that was a truly massive decision, a mammoth decision, as they put it.
And they used principles to guide that.
Absolutely. They called them North Star principles.
Right.
Really clear guidelines.
Give me an example.
Okay, buy versus build.
Their stance was clear.
What was it?
Prioritize using open source. Or even contributing back to it.
Build from scratch only if there's absolutely no other way, if it's truly necessary for a competitive edge.
Makes sense. Saves time, resources.
Immense amounts. Another one, stateless services.
Stateless, meaning
Basically design services so they don't hold on to user-specific information between requests. No sticky sessions.
why is that important?
Resilience. If one server instance fails, any other can pick up the request instantly. No disruption.
And they proved this how? You mentioned something earlier.
Yeah, chaos testing. their famous chaos monkey.
Right, the tool that randomly shuts things down.
Exactly. It randomly terminates instances in production to force engineers to build resilient systems from the ground up.
Wow, that's bold. Intentionally breaking your own stuff.
It is, but it works. Another principle, scale out versus scale up.
Meaning horizontal versus vertical scale.
Precisely. They heavily favored scaling out, adding more smaller machines rather than scaling up, making one machine bigger.
Why? Longer-term scalability.
Much longer runway for growth, yeah. And then there's redundancy and isolation.
Sounds straightforward. Make copies.
Pretty much make multiple copies of everything. Databases, service instances, and isolate different workloads.
To limit the blast radius if something goes wrong?
You got it.
Yeah.
Prevent one failure from cascading. And finally, they really embraced automate destructive testing.
So more chaos monkey type stuff.
Yeah, but ongoing, systematic, constantly trying to break the system at scale, finding weaknesses before customers do.
Okay, so pulling this together, what's the takeaway for you listening?
Well, these aren't just abstract ideas for tech giants, right?
No, definitely not.
Netflix's story just shows how powerful these foundational principles can be. They guided a massive transformation.
Literally shaped the company's future and probably saved them countless headaches later on.
Exactly. It's about embedding resilience, adaptability right into your technology foundation.
Which raises a good question, though. How do you apply principles that robust in your own context?
Yeah, especially when you're facing those typical enterprise challenges. You need structure, but you also need innovation speed.
Right.
Well, frameworks can help. Like the AKQC's Process Classification Framework.
Yep.
Section 8.5.3 specifically talks about developing and managing service or solution architecture.
And it gives practical steps.
Yeah, like assessing constraints, looking for ways to reuse components, how to handle exceptions to the rules.
So like a big retailer could use that for their inventory systems or customer apps.
Absolutely. Across thousands of stores, managing that complexity. These principles are key.
Okay, that leads nicely into the idea of agile architecture, doesn't it?
It does. It's really an approach designed to support agile development practices.
How so?
Through collaboration, keeping design simple, and striking a balance.
Between
Intentional design, the upfront planning, and emergent design, which sort of evolves as you build and learn.
embracing the DevOps mindset, too.
Fully. It allows architecture to evolve continuously, responding to actual user needs right now.
And crucially, it helps avoid that old school big design up front, right? BDUF.
Oh, definitely. Avoids the overhead, the delays of trying to design everything perfectly before you start, and those rigid phase gate processes.
Yeah, those can really slow things down.
From an enterprise solution delivery viewpoint, architectural decisions are fundamentally economic choices
Economic. How so?
because they have a massive impact on how easy or how costly it is to make changes later on.
Right. Future flexibility.
And what's really interesting is the data shows loosely coupled architectures are the single biggest predictor of being able to do continuous delivery.
Loosely coupled, meaning components aren't too dependent on each other.
Exactly. It lets teams work independently, develop and release these small chunks of value streamlets, they're sometimes called.
Okay, but how do you maintain coherence across all that?
That's where the solution intent comes in. It's like the high-level design blueprint.
It maintains the system's integrity.
Right, while still allowing for flexibility for different variants of the solution.
And documentation becomes key.
Absolutely. Architectural assets need constant updates. And documenting key design decisions, or KDDs, is crucial for understanding why things are built the way they are. Makes transitions much smoother.
Now, you mentioned roles earlier. Architecture roles seem to be evolving, too.
They really are. You see all these specializations now.
Like business architects, application, information, technical.
Data architects, security, integration. The list goes on.
Yeah.
And domain architects, too.
Specialists in specific business areas.
Exactly. Deep knowledge.
Yeah.
But the bigger shift is away from these siloed roles.
The current model, like solutions design here, architecture there, engineering somewhere else.
Right. Moving towards a more collaborative, proposed model.
What does that look like?
More distributed responsibility, but with clear governance. You've got corporate tech, core tech, digital governance teams all working together.
And the roles themselves collaborate more. Enterprise architects, product owners, domain architects.
Yes, working across value streams within squads. It's much more integrated.
The goal being?
To be truly product-driven, not just organization-driven, responding to the market, not just internal structures.
Okay. Now, the elephant in the room. You have to talk about it.
Ah, technical debt.
Yeah. That thing that happens when you take the quick fix instead of the right fix.
The expedient solution over the more robust long-term one, it's like taking out a loan.
That comes back to bite you later with massive interest.
Exactly. We've seen some classic painful examples, like the quick and dirty if-then-else.
Tell me about it.
A Canadian company needed a quick fix for a specific sale. Got it done fast.
What?
But they spread these messy changes all through the code base. Later, when they needed internationalization.
Oh, no. Nightmare.
Complete nightmare. A simple update became almost impossible because of that early quick fix.
Okay, what's another one?
Hit in the wall. This team just neglected architectural planning early on.
Didn't think ahead.
Nope. Weeks after going into production, they realized they had to scrap huge chunks of code they'd just written.
Ouch.
And even worse, after a merger, they got a chance to build a new system.
And they still didn't plan to eliminate the old debt.
Failed to incorporate it into the strategy. Just kick the can down the road again.
Wow. Okay, give me another pattern.
Crumbling under the load. This is where a system just accumulates hundreds of little imperfections.
Tricks? Workarounds?
Yeah. Compounded by maybe patchy documentation, not enough automated testing.
And the team knows it's bad.
Oh, they know. They dream of a rewrite. But the business case just isn't there. Too expensive, too risky, so they're stuck patching.
That sounds incredibly frustrating.
It is. And the last one is maybe the saddest. Death by 1,000 cuts.
Ooh, that sounds bad.
It's when there's just this pervasive lack of competence, maybe. Lots of small, avoidable coding errors that just build up.
Why aren't they caught?
Could be many reasons. Unplanned hiring booms, no focus on common standards across products, really limited testing. It's often an organizational problem manifesting as tech debt.
Wow, death by 1,000 cuts. That really paints a picture. It reminds me of my own technical debt at home, that drawer full of mystery cables.
You all have one of those.
These stories are more than just warnings, though. They're really vital lessons, aren't they?
Absolutely. How seemingly small compromises snowball into huge problems.
So the big question is, how do organizations stop getting buried under this stuff? Especially when they're using big, powerful platforms.
Well, connecting back to the bigger picture, a lot of it comes down to decentralized decision-making, but informed decision-making.
Meaning everyone understands the what and the why.
Exactly. Transparency is critical. And that's especially true when you adopt specific strategies, like this idea of a clean core approach.
Okay, clean core. Let's unpack that. What is it?
It's a philosophy, really, gaining a lot of traction, especially in big enterprise environments like SAP ecosystems.
And the goal is?
Preparing for and getting the most value out of cloud adoption, typically. But the principles apply more broadly.
What are the core ideas?
It's about simplifying, standardizing, and really tightly governing your core system, minimizing future problems, maximizing agility.
Built on pillars, you said.
Yeah. Clean code, lean data, controlled modifications, a reliable landscape, clear processes, and effective operations.
Okay, take clean process. What does that mean in practice?
It means using standard solutions and best practices wherever you possibly can. Really good governance.
And only customizing where it truly differentiates your business.
Exactly. Focus custom efforts where they add unique value.
What about extensions, custom code?
That's a big one. The principle is good extension, which basically means avoid them if you can.
But if you have to extend?
Then you need strong governance for what are called decoupled extensions.
Decoupled, meaning they live separately from the core.
Right. Like using a 3-tier model, using released, stable APIs, leveraging proper extensibility tools, maybe on the core platform if designed for it, or side-by-side using something like SAP's Business Technology Platform, BTP.
So any technical debt from extensions is a deliberate choice.
It must be an informed decision. You understand the trade-offs, the long-term cost.
Makes sense. What about clean data?
Focus on quality, accuracy, timeliness, completeness, and efficiency, getting rid of unused data, managing its life cycle, and of course, privacy compliance.
How do you achieve that?
2 parts. Get clean, using tools to cleanse existing data, and keep clean, setting up validation rules, continuous monitoring.
And clean integration, connecting systems.
Key principle, use standard APIs, like OData, SOAP. Aim for loosely coupled, event-driven designs.
And avoid
older, tightly coupled methods like RFC or IDOC if possible. Have a clear strategy, identify existing messy integrations, get clean, and govern new ones, keep clean.
And finally, clean operations.
Just mean integrating this whole clean core idea into your day-to-day operations. Disciplined release management, regular system housekeeping, sticking to maintenance schedules.
Okay, but what about all the existing custom code organizations have? That's a huge hurdle for upgrades, right? For ROI.
Massive hurdle. That's where the 3R strategy comes in.
Yeah.
It's specifically for managing that legacy custom code when moving to new systems like SAP S/4HAM.
3Rs, what are they?
First R, retire. Get rid of code that's not used anymore or that's now covered by standard features.
Obvious, but probably often overlooked.
Definitely. Second R, refactor. Modify the code so it's compatible with the new system.
Like moving it to a platform like BTP, adjusting it for modern programming models.
Exactly. Making it fit the clean approach.
Hmm.
Third R, rebuild.
Starting over.
For critical innovations or extensions, yes. Redesign them properly on a future-proof platform for higher productivity and long-term stability. The goal is a modification-free digital core as much as possible.
This disciplined thinking is really about the economics, isn't it? And managing risk.
Absolutely. Which leads to another useful concept, the traffic light classification for architectural decisions.
Green, amber, red, like driving.
Exactly like driving.
Yeah.
It's a simple way to classify the risk and impact of different choices.
Okay, tell me about green.
Green is the go zone. Standard configuration, side-by-side extensions using platforms like BTP, standard UIs like SAP Fiori.
Low risk, minimal upgrade impact.
Exactly. These align well with the core principles. Functional architects can often approve these directly. Green light means proceed safely.
Got it. What about amber?
Amber means caution. Proceed, but be aware. This includes things like custom fields, custom logic, custom config tables.
Why caution?
They need careful regression testing. They could break during upgrades. They generally increase your total cost of ownership, TCO.
So they incur technical debt.
Yes, a manageable amount, but it's debt nonetheless. You need to understand the trade-offs, often only allowed in specific environments like single-tenant clouds.
Okay, makes sense. Yellow light, slow down, look around. And red.
Red means stop. Think again. Find another way if possible.
What falls into Aura?
Classic extensions using older tools like the ABP workbench, user exits, copying or cloning standard SAP code, directly modifying the core system code.
The really intrusive stuff.
The most intrusive. These will require redeployment or redevelopment after an upgrade. They're typically forbidden in multi-tenant environments.
And incur the highest technical debt.
By far. They can actively prevent you from achieving your core objectives, like smooth upgrades or agility. Requires a very deliberate decision, and usually means exploring green or amber alternatives first.
It's fascinating how these simple analogies, traffic lights, can guide such complex decisions.
It really helps clarify the risks and communicate the policy.
And it all feeds into a concrete planning process, right? It's not just abstract rules.
Exactly. It's about clear communication, shared understanding, discipline. Building software that actually aligns with the business goals.
Knowing when to go, when to pause, when to stop.
Precisely. And that planning starts high level. A strategy map is a great tool for this.
What does that do?
It connects the dots. From the company's big vision, create world-changing tech, be a global leader in ML.
Down to specific corporate goals, strategic goals.
Then measurable objectives, like cut approval time from 25 days to 2 days.
And finally, to specific projects or initiatives, like a Global Growth Initiative 2025.
It creates that clear line of sight. Everyone sees how their work contributes to the bigger picture.
And then you formalize the specific work.
Yeah, with a statement of architecture work, a detailed document.
Outlining.
Project scope, the high-level vision, who's responsible for what may be business and technical architects for a budget approval solution.
Work products, how success is measured, the plan, the schedule, all the specifics.
Exactly, gets everyone on the same page.
Okay, strategy mapped, work defined. How do you visualize the actual solution?
Architects use a series of diagrams for that. First,
Yeah.
a solution context diagram.
Showing.
The business application itself, its main capabilities, maybe existing solutions it interacts with, and the different user groups or roles. Sets the stage.
Then what?
Then a solution concept diagram. This goes deeper into the internal building blocks.
Like workflow engines, rules, data repositories.
Yeah, and how those internal parts talk to each other and to back-end systems.
Yeah. Okay, getting more technical.
A bit. Then solution realization gets even more granular. It shows how those components are actually deployed.
Across different locations, data centers, cloud platforms, specific technologies.
Exactly. Maybe showing SAP S/4HANA here, SAP in a cloud there, a Java app somewhere else, SPUI 5 for the front end.
And finally,
Solution distribution. This maps where the building blocks physically reside across different infrastructure providers.
Like this part's in the public cloud, this part's on-premise, maybe something out on the shop floor.
Precisely. Gives a clear picture of the overall landscape.
And to manage the delivery over time.
That's the architecture roadmap. It shows the phased delivery of work packages.
Like stepping stones, showing dependencies, milestones.
Exactly. For that budget approval solution, maybe phase 1 is build foundation, phase 2 is rollout MVP, phase 3 is automation and simulation. It visualizes the path to delivering business value incrementally.
Okay, this planning seems thorough, but underlying all this are fundamental choices about the type of architecture, right?
Absolutely. And this raises a crucial point.
Yeah.
There's no single best approach. It's always a trade-off. Organizations have choices.
Like the classic monolith.
Right. The single large application.
Yeah.
Pros, lower initial build maintenance cost, maybe less specialized skill needed. Cons, hard to customize, inflexible, slow for new features.
Best for whom, usually?
Often small to mid-sized businesses starting out, where simplicity is paramount.
Okay. Then the opposite end, microservices.
Yeah, breaking things into small, independent services. Pros combine best-of-breed tools, highly customizable, independent scaling, and changes. Cons needs high technical skill, potentially costly to manage many services, can create its own kind of complexity and debt.
Suited for?
Large, mature companies needing high agility. Think big e-commerce.
What about composable? Is that different from microservices?
It builds on microservices, but focuses more on assembling features from independent business capabilities. Pros, huge flexibility, build features without platform impact, pay as you go for features. Cons can get costly as you add services, needs top-tier tech resources.
And the target.
Mature organizations aiming for industry leadership through rapid innovation.
Then there's headless, separating front end from back end.
Exactly. Pros extends functionality to new channels easily, good for personalization, integrates third-party services well, lower tech barrier than full microservices. Cons, still needs talented engineers, can be slower to market initially, potential for debt if IT isn't mature.
That's right.
Businesses starting to break down a monolith, wanting more front-end flexibility.
And finally, hybrid, mixing approaches.
Yeah, often combining monolithic elements with microservices, maybe bundling services from one vendor. Pros, competitiveness, test new ideas like microservices without a full re-platform, often user-friendly tools, shared data, lower IT burden, flexible tech choices.
And this is where most businesses land.
Honestly, yeah. Most find value here, balancing the need for innovation with practical realities in existing systems.
It really underscores that these are economic and strategic decisions, not just tech preferences.
100%. You have to look at your organization's maturity, your budget, your strategic goals.
It's like choosing the right tool, or maybe even designing a new one. And if you do decide to break up a monolith, are there best practices?
Definitely. Key idea. Design the new services around business capabilities, not just single functions. Think order management, not just create order.
And each service should be deployable independently.
Crucial. Developed and deployed individually. That's the agility win.
Big question. Refactor the old code or rewrite?
Often rewriting is better. A lot of monolithic code just isn't reusable in a microservices world. Plus, it's a chance to improve quality, use modern tools.
Okay. How do you pick where to start the migration?
Start small. Pick an orthogonal edge service, something not too business critical, fairly simple functionality, limited dependencies. Learn the process there.
Smart. Minimize risk. What about the actual deployment mechanics?
Use techniques like feature toggles. Hide the new service behind a flag in the monolith initially. Gradually switch traffic over.
Automate the migration.
Automate everything you can. Migration scripts, tests, essential for reliability and speed.
And the operating model changes too.
Big time. Emphasize organizational culture shifts. Strong CI/CD pipelines.
Continuous integration, continuous delivery.
Right. Foster cross-team collaboration. Automate API documentation and implement comprehensive monitoring.
Telemetry, observability, distributed tracing.
All of it. You need deep visibility into how these distributed services are performing together.
Wow. This deep dive really drove home that architecture governance isn't just some static blueprint.
Not at all. It's a living, breathing strategy, dynamic.
For building systems, yes, but also for adapting to a world that just keeps changing.
Exactly. We covered a lot of ground. From Netflix's North Star principles guiding transformation.
To how agile architecture helps speed things up and the very real pain of technical debt.
Then we dove into that clean core idea. The green, amber, red lights for managing risk.
And looked at all those different architectural approaches. Monolith, microservices, hybrid.
And finally, some best practices for evolving those big, complex systems.
Yeah. And I think the core message that came through, for me at least, is that it's all about managing trade-offs.
Informed decisions, that's the key.
And communicating clearly, making sure everyone understands the why.
Couldn't agree more.
So maybe a final thought for you listening. As you go about your work or even personal projects, think about this. How could applying just one of these governance ideas change how you tackle challenges?
Yeah, what technical debt might you be building up right now, even without realizing it?
And what green light principles could you put in place to maybe avoid some future red light roadblocks, something to mull over?